So the next thing your book talks about is something called molar mass. If we get through this as well as Avogadro's number, we are about, oh gosh, 3/4 of the way through this stuff on the chapter. If you look at carbon on the periodic table, you find that there is the number 12.01 in the little box for carbon. 12.01 atomic mass units is the average atomic mass. We've been through how you get the average atomic mass. That number also represents something else. If you have a mole of carbon, which is 6.02 times 10 to the 23rd atoms, the mass of that mole of carbon is 12.01 grams. So this number that you find on the periodic table, this non-integer value, 12.01, okay, that's the atomic mass. If it's a molecule, it's called the formula mass. And if we have a mole of something, you just have the same number but different units, and it's 12.01 grams. 28 grams weighs an ounce, so 12.01 grams is not very much. So how do we define the molar mass, this number you find on the periodic table? It's the mass of any element or compound, the molar mass of any element or compound is the mass of 1 mole of the substance in grams. I forgot to put in grams. And you're always going to find it on the periodic table. It's going to be the prominent non-integer number. Turns out that molar mass is another conversion factor. Which means you get to figure out whether you're going to multiply or divide by it. And what it does, this conversion factor, it allows us to convert grams to moles or moles to grams. And at this point you're going, I hardly know what a mole is and you want me to go converting it? Yep, we're going to practice. So if you go back to carbon and you find this on the periodic table as 12.01, and AMUs are too small to weigh, and we can weigh grams, you can say there's 12.01 grams in any 1 mole, or you can say 1 mole is found in 12.01 grams. Again, an equality makes up a conversion factor because these two amounts are the same for carbon. So if I want to use it as a conversion factor, let's take 36.03 grams of carbon. And the question says, how many moles are there? Well, you know, when you do one of these problems, if you want moles, whatever you're asked for in the problem has to be the top on the conversion factor. So we can look at these two, and this is the one with moles on the top. 1 mole in 12.01 grams. All right, the grams will cancel. And if I divide 36.03 by 12.01, I'm going to end up with 3.0 grams. This should be like 1.00 moles up there. I wasn't very careful with my sig figs. But that's one way to use the molar mass as a conversion factor. On the other hand, suppose I want to know how many grams are in a half a mole of carbon. I would take 0.5 moles of carbon. My question is asking for grams. I'm going to multiply by a conversion factor, and I want my answer to be grams. So I'm going up here. This one has grams on the top, moles on the bottom. 12.01 grams in 1.0 mole. The moles of carbon will cancel, and I'm going to take 0.5. I'm going to multiply it by 12.01 grams, and I get 6.005. Let's just call it 6.0 grams of carbon. Okay, so that's not too bad. Now things get kind of nasty. Sometimes you need to use the molar mass and Avogadro's number at the same time. If you use them together, it allows you to go from grams to moles to atoms, or from atoms to moles to grams. These are supposed to be arrows, okay? Not half arrows. To go from grams to moles, you're going to use the molar mass. And to go from moles to atoms, you're going to use Avogadro's number, or 6.02 times 10 to the 23rd. Okay? So if you needed to do a problem that went all the way from grams to atoms, you would need to use both things as your conversion factor. Now, we've already done moles to atoms and atoms to moles. We've done grams to moles and moles to grams. Now, let's try a harder one. So the question says how many atoms, that's what we're looking for, are in 24 grams of carbon. Making up a roadmap, I have grams. There is no direct way to go from grams to atoms. You have to go through moles. So I'm going to go from grams to moles to atoms. Remember, the abbreviation for mole is MOL. Okay, now I've got to look at my units. 24 grams of carbon. I need to get to moles of carbon. That means carbon, the moles has to be on the top, 1 mole in 12.01 grams. And now I need to get to atoms. Means atoms has to be on the top, 6.02 times 10 to the 23rd atoms in 1 mole. Handwriting is horrible, I know. 24 divided by 12 is going to give you a half, and a half times, it's going to give you 2, and 2 times 6.02 times 10 to the 23rd is going to give you 1.204 times 10 to the 24th atoms. Okay, so we've done that. We've used both of them. Let's go backwards. We're going to start with atoms. Atoms here, atoms there. We're going to go to grams. So the roadmap is going to be atoms to moles. Moles are always in the middle, to grams. Okay, taking my given 1.8 times 10 to the 24th atoms of carbon. Now I need to go to moles. So how do I go from atoms to moles? I use Avogadro's number. I want moles on the top. That's what I'm looking for in this step. So I'm 1 mole divided by 6.02 times 10 to the 23rd atoms. Remember, you divide by anything in the denominator, atoms and atoms. They're going to cancel. At that point, you're left with moles. But the question says how many grams. To go from moles to grams, you use the molar mass. I want grams on the top, and I want to get rid of moles. And I know that there are 12.01 grams of carbon in 1 mole. So for this one, I'm going to have to take 1.8 times 10 to the 24th, divide by 6.02 times 10 to the 23rd, which is going to give me around 3, and then multiply by 12.01, which is going to give me 36.03 grams of carbon. Okay, and at this point you're like, oh, please, please make her stop. Not yet. So, if you do not like dimensional analysis, if you absolutely hate dimensional analysis, you just write down this little chart. Okay, you put grams at the top, moles in the middle, atoms at the bottom. Arrows on the left side go down, arrows on the right side go up. And so to go from grams to moles, you divide by the molar mass. So you follow the arrows and do what it says. To go from moles to atoms, you multiply by Avogadro's number. Again, we're just following the arrows and doing what it says. To go from atoms to moles, we divide by Avogadro's number. That's a division sign. And to go from moles to grams, we multiply by the molar mass. So you can use it for this part, just going back and forth from grams to moles. You can use it for this part, moles to atoms. You can use it for the whole thing, grams to moles to atoms, atoms to grams to moles, atoms, moles to grams. So let's see, if we want to go from grams to moles, we're just going to do this part right here. That little bitty bit. We're going to divide by Avogadro's number. If we want to go from grams to atoms, we're going to have to go from grams to moles and then moles to atoms. We're going to have to do both of them. If we want to go from moles to atoms, we're starting here at moles. We want to go to atoms. We're going to do just that part. And if we want to go from atoms to moles, somebody said, yeah, atoms to moles, we're going to just reverse that like that. And if we wanted to go, of course, from atoms back to grams, we would have to do the whole thing. We'd go from atoms, I'm making a mess out of this, I know, to moles, and then finally to grams. So you just go back and forth on that diagram, and you don't have to do any thought about units.